Okay, so all of the things that we know in regards to trigonometry still apply. We just express them now in radians rather than in degrees. So if we're looking at our exact ratios, we've got our isosceles triangle, the sides are 1. So we know that one of the angles is 90 degrees, the right angle, which is pi over 2. The other two angles are pi over 4, because 45 degrees is 180 divided by 4. Okay, so these angles here are pi over 4, so is this one. And using Pythagoras, we know that if it's 1 and 1, then the hypotenuse is root 2. So from that, we can say that sine of pi over 4 is equal to 1 over root 2, and cos of pi over 4 is going to be the same thing. And that tan of pi over 4 is opposite over adjacent is just 1. Okay, again, nobody expects you to memorize these, just spend the whole 20 seconds writing it down and working it out. So in case you forgot, we come up with the other angles by starting off with an equilateral triangle. So if we start off with an equilateral triangle, we know that the angles are equal to 60 degrees, and if pi is 180 degrees, then 60 degrees has to be pi over 3. So this angle here is pi over, pi over 3. And we start off with side length 2, because what we then do is cut our equilateral triangle in half. So when I cut the equilateral triangle in half, I now have this side length here of 1, because you drop it down the middle and it bisects it. And then the same thing happens to the angle, so instead of pi on 3, the angle is now pi on 6. And again, Pythagoras, 1, 2, so this side here must be root 3. Okay, so from there we get our other exact ratios. So sine of pi over 3, so opposite over hypotenuse is root 3 over 2. Cos of pi over 3 is 1 on 2. And tan of pi over 3 is 1 over root 3. Sorry, root 3 over 1. So it's just root 3. Okay, so sine of pi over 6 is 1 over 2, and cos of pi over 6 is equal to root 3 on 2, and tan of pi over 6 is equal to 1 over root 3. So everything that we know about it still holds. Sine of one angle is equal to the cos of the other angle, as you can see, and that tan of one angle is the reciprocal of the other angle. All of those relationships still exist, they haven't changed. We're just using radians instead of degrees to denote the angle that we're talking about. Okay, so if we are asked something like this, cosec pi on 4, so you need to think about what you thought about before. Cosec, we know, is the reciprocal of 1 over sine, yeah? So this is 1 over sine of pi over 4. And then you would go back to your triangle that you drew right at the beginning of the exam when they said pick up your pens, and you would say that sine of pi over 4 is equal to 1 over root 2, but cosec is the reciprocal, so this is equal to root 2. Okay? Now, your circle and your quadrant, all of that information still applies. So we're going to go through how we set this up in radians, okay? So if we start here still, this is our 0, yeah? And then we know that 180 is pi degrees, okay? Which means that 90 is pi over 2, and 270, well, that has to be 3 pi over 2. Okay? It is still all stations to central. That stuff all still applies. So what angle are we talking about in the first quadrant? Well, in the first quadrant, we still just use theta, because they're all positive and they're all less than 90. So there's nothing that we need to do there. if we move into the second quadrant, well, now sine is positive, and we are now looking at, instead of 90 minus theta, it is pi minus theta. Okay, so if they wanted you to work out 160, you would say, well, that's 180 minus 20, so I need to work on an angle of 20. Okay, same as before. Okay, in your third quadrant, tan is positive, and in this case we are working on pi plus theta. Okay, so if it was 225 degrees, then we would be working on 180 plus 45 degrees. And then we go from there. And in my fourth quadrant, we work on 2 pi minus theta. So we go to 360 and come back. Same as we did when we were working in degrees, okay? So let's have a look. Some of the questions that we've got sine of 5 pi on 4. So the first thing you need to do is say, which quadrant is that in? Well, 5 pi over 4. Look at your fraction. 5 over 4, that's more than 1. It's greater than 1. So we've moved past pi. We've moved past 180, so we are in the third quadrant. Okay, so in the third quadrant, what do we know? We know that sine is negative. So we are going to do a negative answer here, and we know that we have to look at the angle that is being added to pi. Okay, so 5 pi over 4 is equal to pi plus pi over 4. Yeah, so it's this angle here that we need to consider. Alright, so we say that sine of 5 pi over 4 is equal to the negative of sine of pi over 4. Well, we know that sine of pi over 4 is equal to 1 over root 2. Therefore, this is equal to negative 1 over root 2. Okay, so same process as before. Okay, so the next one's a bit complicated. Sec of 11 pi over 6. So sec is related to cos. That's the first thing we need to consider. So we're working with the cos ratio. And the second thing is the 11 pi on 6. So think about your fraction, 11 over 6. We're almost at 2 pi. This puts us into the fourth quadrant, 11 pi over 6. So we're working with cos in the fourth quadrant. So we know that cos in the fourth quadrant is positive. And we know that we are working with 2 pi minus, so think about it, it's 2 pi minus pi over 6, because that's what's equal to 11 every time, 11 pi over 6. Okay, so we need to work out what cos of pi over 6 is. So cos of pi over 6, go back to your triangles. Cos of pi over 6 is root 3 over 2. Therefore, this one is equal to 2 over root 3. That's it. Okay, you can skip question 1 because that just goes through the exact ratios and we've already worked them out and written them down. So start at question 2, make sure you're doing some of each. Good luck, I'll see you in class.